Solving systems with matrices. So when you have the x's and the y's and the z's with letters, the equations with letters is a system of equations. But if you remove the letters and you write it like this, then you say you're working with matrices in this form. Notice where these came from. The 2, the -3, the 1, and the 5 came from the numbers in front of the letters. We call those coefficients. This is the variable matrix. What might be confusing here is that even though this has x and y, we're calling all of this x. So you pick whatever letter you like. That tells the reader that these are the variables, what we're looking for. Then we have the equal sign, and then we put this numbers in another matrix. So this is called the coefficient matrix, the variable matrix, and the constant matrix. You first set it up like this. Here's another one. Here's a system. There's a 3 by 3, has 3 letters, 3 variables. Notice these numbers are the numbers in front of the letters, are the coefficients. And if the letter's not there, well, you put a 0. And this bar is the equal sign. These are the constants. Here they are. So this one that you see here is called an augmented matrix. You get this piece and you make a matrix out of it. You put the 3 variables. That as another matrix is a variable matrix. And finally, you put an equal sign, and this is the constant matrix that came from here. So how do you use these matrices to solve systems of equations? Okay, you could solve them as a system as we did in previous sections, or you could use matrices. So you set it up. So these are the numbers in front of the letters, the variables. This is our variable matrix, the 2 variables we're looking for. And this makes the constant matrix. So I need to get the variable matrix by itself. So I need to move this matrix to the other side. So if these were numbers, real numbers, we would take the reciprocal, right? We would divide. But in matrix rule, that does not exist. You have to multiply times the inverse. So this one, when you move it to this side, you call it inverse. That tells us this came from the other side. So how do you find the inverse? We have to find the inverse to continue the multiplication, right? So how do you find just the inverse? Well, there's different ways. This is one of the easier ones for a 2 by 2. There happens to be a formula for a 2 by 2 matrix inverse. So A, B, C, D. These positions have names of letters A, B, C, D. Notice the inverse symbol. And you just follow this placement of the numbers inside the matrix. Notice this is the A, so it's going to go here. This B is going to go here. This is a D, is going to go here. This is a C, is going to go here. A, B, C, D. So you plug them in there. Notice this is where these came from. This is the A. This 3 is what? The D, right? And then there's a minus. This minus is always there. So you plug them in here. And what is this? This tells you what you need to do to the numbers. You have to do something else to them. So notice you start off with A, B, C, D. And these that are here, you switch them around. Notice the D's up here and the A's down here. These, you leave them where they are and just put a negative on. So this is your recipe. So we did this already. So notice the 1 used to be here, but look at where it is. The 3 used to be here, and look at what it is. These 2 numbers are the same, but they have a different sign. They should have a negative also. So if it was a negative, it becomes a positive. If it's a positive, it becomes a negative for these numbers here. Now you simplify, you do the multiplications that explanation has. So notice right here in this case, you always have a 1 here. It's always 1 divided by these numbers. The way the formula says it's always a 1. In this case, we have a 3 minus 3. That doesn't happen sometimes. It happened this time. So as soon as you see a division by 0 in any math problem, you stop because you can't divide by 0. So if this would not been a 0, I would have multiplied this number times each one of those, and that would have been my answer. But since I have a division by 0, everything stops. Since there's a division by 0, there is no solution. There is no inverse. So there's no inverse here.